Everyone, welcome back to Code with Kari. So from today we are going to start a very important data structure, which is trees. So what is a tree? Tree is basically a non-linear data structure where each node is connected to multiple nodes. Like if you remember, if you saw the previous playlist, which is based on linked list, there each node was connected to either two nodes, which was either front or back, right? There was no multiple nodes, but here each node can be connected to multiple nodes. The count can go until 1, 2, 3, 4, 5, 6, n number of times. So yeah, this is how a tree basically looks like. So this right here, the circle you see, if I name it, suppose if it's a node. So a node consists of two things. It has this data, which will be a, the value, and another thing will be have is three pointers. If we take case of this thing, this diagram right here, we have three pointers which are pointing to this three nodes which A is connected to, right? So this right here, and this. So these are the these three nodes which A is pointing towards. So yeah, now moving on to binary trees. So what is basically a binary tree? So binary tree is any tree which has like 0, 1 or 2 child nodes only. So like take example of this right here only, okay? Here A we have, A has two child nodes, right? B and C. And B has two child nodes, D and E. D has 0, E has 0, C has 1 and F has 0. So this right here is a binary tree. So what is A? Before moving on to the next before moving on to the code, first of all, let's learn some terminologies we have here in binary trees. So this A will be the root node because it's a root node, right? So F will be our leaf node. What are leaf nodes? Leaf nodes are the nodes which don't have any child nodes, okay? Which don't have any child nodes. So D, E, and F, all three will be our leaf nodes. Now we have a parent node here. So what is how come C can become a parent? C can become parent of F if F becomes a child node. Yeah, right. So A can become a parent of B and C. B can become parent of D and E, and C can become a parent of F. So this is how this works. We also have things like descendant and ascendant. So like if I say A is the root node, right? So we can say D and E are ascendants of descendants of A, right? F is also a descendant of E. So that is how it works. So yeah, let's try to code it now. Yep. I'll write the basic boilerplate. By the way, yeah, if you do want a video on how I wrote this boilerplate, do write in the comment section. So first of all, I'll make a class node. Uh, right. We'll start it with two things. One was data, int data, and another was pointers, right? We had two pointers for binary trees. One being the left pointer, and another being the right pointer, right? So I'll just write those pointers. Also, now let's write a constructor. Let's write a constructor for this. So as soon as I write node, I'll pass in root. So node star root. So this data will be equal to data, and this dot. Initially the pointers will be null. The left pointer will also be null, and the right pointer will also be null. Right, yeah, that is it. So let me call, oh, I forgot the semicolon here. Okay, so let me initialize the node. Suppose I name it root is equals to initially it will be null. So yeah, now we have to write a build tree function, right? So yeah, let's write a void build tree. I'll pass in root. I'll pass in root. So just as a pass in root, first of all we need the data, right? Int data. So we make sure that we see enter data. Before that, I'll just see out that enter data, just to make our work easier. Enter the data. So yeah, once we have the data, what we'll do is oh yeah, I forgot. I should also give handle here. Okay. So now, if for the base case, I will write as if data is equals to -1. If data is equals to -1, then you can just return the null because we are using recursion to build a tree here, right? That's why. So see out. Now we'll take the data of left and right child. So enter the data to left of, enter the child, should I write, or anything is fine, child to left of, suppose I write data here, suppose I write data here. So, and okay, so we'll call the build tree function. So root, if root col left is equals to build tree, and we'll pass in root left. Now we'll go for the right child. Right, enter the child to the right of data, right? So again, root right will be equals to build tree root com, right. Oh, I forgot to, why is it giving errors? I thought so it's because I forgot to like create the new node here, right? I should have created a new node. So root will be equals to, so every time we get a data, a new node will be created. I forgot to create it. So yeah, and we'll be passing in root. So yeah, I think that should do it. Let's just check for any errors we have. We are passing in root. Yep, it did all. Yeah. Okay. I'm wondering why is there we have a lot of errors here. A value of type void can't be. Oh, it's because it shouldn't be void. No, it should be of node pointer type. Yep. And we'll be returning root. Return root. Yeah. See that this was the possible error because we were writing void, but we have to return root here. Right? Oh, it says inaccessible because I forgot to write public here. Public. Now it won't give us an error. Yeah. See. Yeah, it's important to make it public, right? So before that, I'll write is equals root is equals to build tree. I'll pass in root, and yep, let's hope for the best. Return 0. So let's see if our node is. Suppose this is the tree we are trying to create. Okay, 1 it has childs 3, 5, and 3 has childs 7, 11, and 5, 17. So suppose this is the tree we are trying to create. I wrote it because it was important to know. So yeah, now let's try to run it. So first data we have is root node 1. Enter child to the left of 1. Oh yeah, I forgot to give here cout. My bad. Data. Tell, and the same thing here. Yep. So yeah, enter data 1. So it says enter child to left of 1. So left of 1 is 3. Enter child to left of 3. Left of 3 we have 7. Enter child to left of 7. We don't want anything, so we'll write -1. Remember the condition. If it's -1, it will return null. To the right of 7, we have to enter -1 because we don't want anything. So now we have here enter child to the right of 3. So what is at right of 3? We have 11. Enter child to left of 11, it is -1 because we don't want anything, means it will return null. So now right of 1, we have 5 here. and a child to the left of 5. We have, what do we have left of 5? We have nothing, so we'll return -1. What is right of 5? We have 17, right? What is to the left of 17? We have nothing, and right of 17 also nothing, so we'll return -1. So yeah, now the tree is built, right? So now we have created the node, right? But we don't know how to traverse it. So what we'll do is we'll write a function for we'll learn something new, which is level order traversal. Order traversal. So what happens in level order traversal is, suppose this is a tree, right? So what will happen is we'll print 1 first, and then we'll print 3, we'll print 5, we'll print 7, 11, and 17. Just the order of the tree it is. Right? So yeah, let's try to print it now. So I'll write a function void level order traversal. We'll pass in root. So once we pass in root, what I'll do is I'll store this all of the nodes in a queue. I'll make a queue. So queue of type node star, because we are storing nodes, right? And I'll name it queue. So first of all, what I'll do is I'll push in root, and just after I push root, I'll push null. Because why am I pushing null here? It's because null will be a separator to to print out on the next line, right? So like suppose if I fill in 1, so once I enter the root, what we'll do is null, enter null, push null. So once null is pushed, what we'll put a condition here, like if null is equals to, means if q dot front is equals to null, then just see out and null. So yeah, so I'll put in the condition here, while our queue doesn't go empty, while our queue doesn't go empty, what I'll do is I'll make a, first of all I'll make a temporary variable which will be for our front of our queue dot front. So once that is done, we'll just pop it. So yeah, and we'll write a condition here, if temp is equals to null, then remember I told you about the separator. So yeah, this is the case which we were talking about, cout and l. And also if q is not empty, means there is still a child node over there, right? If q is not empty, then q dot push null. And now we are going for the left and right childs of the root node. So first of all, we will print the data. And if there exists a left child of temp, then just push it, q dot push the left child, and the same condition for right. Yep, that is it. So yeah, and I think that should do it. And now let's try to print it. I'll call in the function, what was the name we gave it? Level order traversal, right? Level order traversal will pass in root. Yep, let's try again. Enter the data. Oh yeah, I should have returned it over there. No worries. I'll just enter it again. Before that, I'll just clear our terminal. There's a lot going on over there. So yeah, so this is a tree, right? We have 1, we have 3 of my pack. Let's try to do it again. We have 1, then left of 3, then we have left of 3 is 7, then -1 and -1, then 3 we have 11. For 11 we have -1 and -1. And then for 1 we have 5. For 5 the left child is -1, and right we have 17. For 17 we have -1 and -1. So yeah, as you can see, we have some, I mean, it's returning values, but it's definitely returning garbage values for some reason. I think I figured out the error. It's because we are in constructor. I don't know why did I pass uh, node. We are passing in data here, right? For constructor we should pass data, then only the node will be created, right? So yeah, node matches the argument list. Yep, I think it should work now. Still there's one error. No instance of constructor node matches the argument list. Oh, because it's data which we have to pass here, not root. So yeah, I wrote down the inputs here, so I'll just copy paste them and we'll run enter. So yeah, as you can see, this is the tree we have here. So this is the tree we wanted to build, and we have the tree here, right? Awesome, let's go. 1, 3, 5, 7, 11, 17. Yep, thank you. That's it. So for the next lecture, we will learn about in order, pre-order, and post-order traversal. Yeah, see you later in the next video.